All right, now we're going to discuss applied differentiation. What this means, it simply means word problems. How this stuff, how derivatives can be used in real world examples. So here are the steps that we need to solve these applied differentiations. First, you have to read and understand the problem. Then it helps to test if we understand it. Draw a picture and label the pieces. That way, that's a graphic representation of what you think you understand. Then introduce, actually, it's defining the variables. If you deal with time, t, with the distance, s, and anything else you just put as x, just whatever you define them, make sure you define the variables as they're stated. The next is the most important part. Then write the equation for the unknown value. Because at this point, this is where you have your equations and your variables, and this is where you connect all of them. Because in order to solve a problem, a math equation, you can only have one equation and one variable. So this is where you connect them all. Then work out the problem. And then lastly, test the critical points. And the endpoints of the specific domain of the variable. What this is going to do is make sure that you're within the range, the bounds of what it's saying you're supposed to be. Right? So let's look at the first example. Example 1. An open top box is to be made by cutting small congruent squares from the corners of a 12-inch by 12-inch sheet of tin. And the sides are made by folding or bending the sheet to the cut corners. There's a question. I mean, there's a statement. Now here's a question. How large should the squares cut from the corners be to make the box hold as much as possible? All right, so let's see what this is telling us. So what information is it giving us? Well, we have a 12 by 12 inch sheet of tin. That means it's a square. You got 12 inches here, and you got 12 inches here. Right, so that's what this part tells us. Now, the next part is you have to cut small congruent squares from the corners. Small congruent squares. So these have to be squares, and congruent means the same. So each of these corners has to be cut the same. How big is the cut? Well, that's what we have to figure out. That's the x of our equation. Because they're squares, they all have the same sides. And we figure out how big do we cut them. Our quest is figure out as much as possible. So this is a maximum problem. So once we cut these corners, we fold up the sides. We will have an open top box. That's what it's going to look like. So now we have to figure out what formula do we use. Since we're looking at as much as possible, and it's a box, that is defining the volume. We want to know how much we can put inside there, so that's the volume. And the formula for volume of a three-dimensional object is base times width times height. We have the base, the width, and the height. So the only thing we know we can define so far these variables is this wall was made by this cut. So once we cut them, we fold it there. So that gives us this wall. We cut these, we can fold it here, we get the front. We cut these, we can fold it there, we got the other side, and we fold it there, and we got the back side. So the height is what our x variable is. Right, so that's what h is. Now we have to figure out what the base and the width are. Well, since it's a square, and these are all congruent squares, base and width have to be the same. It's going to be a square box. So how big is the side? Well, they're 12 inches, but we're cutting away this x and that X. So it's 12 inches, and you take away these two X's. So that's this length right here. And it's going to be the same thing for this length here. It's going to be 12 minus 2X. So the volume equals the base is 12 minus 2X times the width, which is 12 minus 2X, and the height is X. So we can write it. Okay, so that's what we have to use to solve for it. So there's our formula. We have X. We see we have one equation and only one variable. So that's going to be pretty easy. So what we have is X times 12 minus 2X squared. Since we're looking for a maximum, we first have to find the domain. What is our domain? I mean, how big and how small X's can we use? Because remember, we have a box made from a square piece of tin. Cut congruent squares out of the corners. And these sides are all 12 inches. So what we have to do is we're going to have to take our volume, because it's a cubic equation, set it equal to 0 to find our X intercepts, our solutions. So we could do that. So if we set X equal, this equals 0, then we take both of these. We take X, set it equal to 0, and we take 12 minus 2X, set it equal to 0, because inside there. So we have 12 minus 2X equals 0. 12 equals 2X. I'm moving this one over. Divide by 2. So X is 6. So what this tells us, the domain of X's we can use. Here's our volume, and here's our X. The smallest we can use is 0, and the biggest we can use for X is 6. And it's going to be a curve of some sort, so because it's a cubic equation, it'll be some sort of curve. All right, now, what does this mean? Well, if the X is 0, if these X's are 0, you don't cut them, and you fold them up, what you're going to have is just a folded sheet that looks like this. And the volume is 0 because you can't put anything inside there. Now, if you have 6, then it's going to be 6 inches in the middle, 6 inches in the middle. I'm sorry. This one's going to be, because these are each going to be 6 inches tall. Because if you cut this to be 6 inches, cut this one to be 6 inches, you're just going to fold it in the middle. You get this one. If it's 0, you're just going to have that sheet. There's no area there. So we're looking for something in the middle, somewhere in the middle, because we're looking for the highest volume possible. So let's figure out how to solve this. We first have to do this 12 minus 2x times 12 minus 2x. We have to FOIL that. 12 times 12 is 144. Negative 24 minus 24 is negative 48. And then positive 4x squared. Right? Distribute, get rid of the parenthesis, so and rearrange them. We have 4x cubed minus 48x squared plus 144x. So that's our equation. To find the extrema, we need b prime. So from here, we find v prime of x, because this is actually a function of x. So that's going to be 12x squared minus 96x plus 144. So to find the extrema, we need v prime, and then we have to set it equal to 0. Okay. Let's make it easier for ourselves. Since these are all factors of 12, we can take out a 12, leaving us with x squared minus 8 and plus 12. We can factor this equation out. So we have x and x, because it's a quadratic equation. Signs a plus, so both the same. They're both minuses. What times what is 12? When you add them, you get 8. 6 and 2. Set them, so solve that, we get x equals 6 and x equals 2. Those are our possible solutions. But we found out that we can't use 6 because that's going to make it 0. So we can't use this. So our solution, the cut that we have to make is 2 inches. This is the corner cut. Is 2 inches. So the volume, when x is 2, will be x 12 minus 2x squared. 2, 12 minus 2 times 2 squared. 12 minus 4 squared. 12 minus 4 is 8. 8 squared is 64. So it's 128 cubic inches is our volume. That's our answer. All right, so that's how we do it. We drew a picture, we explained what we had, what we're looking for. All right, let's look at the next one. Example 2. You're asked to design a 1 liter can. Shaped like a right circular cylinder. What dimensions will use the least material? Okay, so what do we know here so far? We have to make a right circular cylinder. It's got to hold 1 liter, and we're looking for the least material. So let's draw the picture. What is a right circular? So it's circular. It's a cylinder, like a can. And it's right circular. That means these form a 90-degree angle in the corner. That's what that tells us. It's got to hold 1 liter. Why is that important? Because we're looking for material and we're giving a liquid measure. So we have to use this conversion. Because we have to go from 1 liter and we have to change it to some distance measure. And that equals 1,000 cubic centimeters. This is the conversion we have to use to change from liquid to solid. That's pretty cool. And since we're looking at the most material possible, we're given this. We're given the volume of the can. So we know what the volume has to be. The volume is going to be pi r squared h. Now, so what material do we have here? We have this top part of the can and the bottom part of the can. So that's the material there. That's the area of it. The area of a circle is pi r squared. So that's the bottom is area is pi r squared. And then we have the height. Okay, now we're looking for the material. So if we took this can and expanded it, what we would have is we'd have a either a rectangular or square sheet with the top and the bottom of the can. This is the top and this is the bottom. Because if you put this stuff together, you'll end up that. So you take this sheet of paper of whatever material you have, aluminum, fold it over. So there's the beginning. You put it here, roll it around, you have that. And the top goes up here and the bottom goes down here. And there's your can. So now we have to do, so since we're looking for the outside material, this is important, but not just for yet. But what we're looking for, what this question is asking for us, is what is the complete area of the can? So what are these areas? Well, we have the top, the bottom, and the side. So the area of the top, the area of the circle, the area of a circle is pi r squared. All right, 2 pi r, I mean. 2 pi r. No, pi r squared is the area. I'm thinking of this one here. Pi r squared. So the top is pi r squared. The bottom is pi r squared. And the side is the circumference. It's the outside of a circle. The circumference of a circle is 2 pi r. So putting all this stuff together, the area is 2 pi r squared plus 2 pi r. That's the formula. And then we have to have the h, because we have the area, this is 2 pi r times the h. All right. Now we gotta start putting all this stuff together. What we know. This part here is important because of our equation here. 2 is a number, pi is a number, then we have r and h. We have to figure out exactly what h is, but we have to make h in terms of r. And that's where we use this. We know the volume is pi r squared h. So we have to take this equation and solve for h. So I divide both sides by pi r squared. So h is equal to the volume over pi r squared. That's our h formula. Right? So now we know our volume. We know our volume is 1,000 cubic centimeters. So the V is 1,000 cubic centimeters over pi r squared. So there's our formula for h that we're going to use in our equation. So we take this equation, we take this conversion of liquid to solid to liquid, liquid solid, and put them together. So we have area equals 2 pi r squared plus 2 pi r h. Area is 2 pi r squared. H is this. H is 1,000 over pi r squared. Now we got to simplify. The pi's cancel. 1 r cancels here, so we have 2 times 1,000 over r, which makes our formula 2 pi r squared plus 2,000 over r. That's the formula we'll be using. All right, so let's see what we need so far. Remember, the radius has to be positive. It can't be 0 because then we just have a point, a stick. So we have to have some radius. It has to be a positive. We need the minimum of the area. So the area is 2 pi r squared plus 2000 over r. We can rewrite this as 2000 over r becomes 2000 r to the power of -1. Because, well, remember, this is a function with respect to r, because that's the only variable we have. So to find the minimum, we need a prime of r. So take the derivative of a, which makes, with respect to r. So forget, this is just a constant. Bring the 2 down. 2 times 2 is 4. And this one, take the derivative of this one. So you bring down the, we have negative 2000 r and subtract 1 makes it -2. Makes it negative 2000 over r squared. So it makes it negative 2000 over r squared. To find an extrema, we take the first derivative and set it equal to 0. The fraction, get rid of the fraction, multiply everybody by r squared. So r squared times r makes it r cubed, and the r squares canceled. Solve for r. So move the 2000 over, equals 4 pi r cubed. Divide by 4 pi. So r cubed is equal to 2000 over 4 pi. Well, the 4 goes into 25 times, so this becomes 500 over pi. Get rid of the cube by cube rooting both sides. So r is equal to the cube root of 500 over pi, which is approximately 5.42. And that's our min. That's our radius, so centimeters. Why is it centimeters? Because of our conversion. Our conversion, we changed to centimeters. So all our units are centimeters cubed. Okay, so that's our radius. But now let's figure out the height, because we had that one h value in there. And h, remember, was the formula was 1000 over pi r squared. So 1000 pi 5.42 squared. It becomes approximately 10.84 centimeters. So our height is approximately 10.84 centimeters. Those are my dimensions. The next example. Example 3. A rectangle is to be inscribed in a semicircle of radius 2. What is the largest area the rectangle can have? And what are its dimensions? All right, so we have some words in here. So let's draw a picture. We have a rectangle inscribed in a semicircle of radius 2. So we have a semicircle. Its radius is 2. Semi means half, circle, so half a circle. And a rectangle is inscribed inside there. What is the largest area, the rectangle? So we're looking for the area of this rectangle. All right, so what do we know? The largest area, because in order to find the area, that's going to give us this. If we have this, if we know the area of this box here, then we double it. So if we have this area plus this area, that's 2x times y. Because x is from 0 to some value x and up to some value y. So we need to know this point. It's x and y. So what exactly is y? How do we figure that out? Well, because this is a semicircle, what this is looking for here, we can determine what y value is by using Pythagorean's theorem. Because remember, the equation, the formula for a circle is a squared plus b squared equals c squared. X squared plus y squared equals the radius squared. The only thing we know so far is the radius is 2. So we have x squared plus y squared equals 4. We don't know what y is, so we need to find the equation of y with respect to x, because we can only have one variable inside here. So move the x over. It gives us y squared equals 4 minus x squared. Square root both sides. Y equals square root of 4 minus x squared. Yes. I know what you say is whenever you square root a squared number, you have to put a plus or minus in front of there. But we have to use the y value has to be positive. It can't be negative. If it was negative, it'd be down here. So we're only using the positive value. So this is what y equals. Plug that in here. So area of the rectangle is equal to 2 times x times square root of 4 minus x squared. This is our formula for A, the area. To find the extrema, so the largest area, extrema, we need A prime. So A prime is actually a value of x, which is the rate of the rectangle. What we have to do here, we have to use the product rule. So f is 2x, g is square root of 4 minus x squared, which is 4 minus x squared to the power 1/2. Then we need f prime, which is 2, and g prime, which can be a chain rule. Take the top, bring the power down. Subtract 1, we get negative 1/2. Times the derivative of the inside, which is negative 2x. So the 2 and the 2 cancel. So what we have is negative x, and this goes on the bottom, 4 minus x squared to the power 1/2. And we use plus since it's a product. So it's going to be 2 times 4 minus x squared to the power 1/2. Negative x times 2x is minus so it would be negative 2x squared over 4 minus x squared, which can be rewritten two radical 4 minus x squared minus 2x squared over square root of 4 minus x squared. For extrema, we take that and set it equal to 0. So we have 2 radical 4 minus x squared minus 2x squared over square root of 4 minus x squared. So we move this one to the other side. They give us 2x squared over square root of 4 minus x squared equals 2 4 minus x squared. Since we have a fraction, multiply both sides by the denominator to get rid of it. By the LCD, I should say. So these cancel. So we have 2x squared equals 2. That times that, since it's radical times radical, radical cancels. We're left with 4 minus x squared. Get rid of the parentheses. When we have one x is both the same, so we add 2x to both sides. So we have 4x squared equals 8. Divided by 4. X squared equals 2. Square root both sides. we get x equals plus or minus square root of 2. So x equals negative square root of 2, and x equals positive square root of 2. We can't have a negative distance, so this has got to be our solution, our value. So the area of our rectangle is 2xy, and y, remember, was the square root of 4 minus x squared. So what we're doing here is putting the square root of 2 inside there. 2 times square root of 2, 4 minus square root of 2 squared. So it's 2 square root of 2 square root 4 minus the square root and the square cancel. 2 radical 2. 4 minus 2 is 2. So we have 2. Radical 2 times radical 2 is radical 4, or radical 2 squared. That makes it 2 times 2, and that equals 4. So the largest area that we can have is 4. So our dimensions. What we're looking for, the dimensions of the rectangle. So the length is 2 times the x value, which is 2 times square root of 2. Why is it? Because remember, we had this area plus this area. So the length is this plus this. And the height is the y value. That's the square root of 4 minus x squared, which is square root of 2, which we just calculated right there. So this is the base times the height. All right, now let's switch the view of how we use calculus. So far, we've looked at physics and motions and stuff. Let's look at economics or in business. We're always looking for a profit when it comes to business. Profit is defined as the profit made by making this many objects. What is a profit made up of? It's made up of a revenue, which we define as R of X. That's selling that many objects. And then we also have the cost of making those objects. So of making and selling X items. Now, we look at rate of change. That's what we're looking at in this first half of this course. In business, those are called margins or marginal. So the marginal profit would be the first derivative of your profit. The marginal revenue is the first derivative of your revenue. And the marginal cost is the first derivative of your cost function. So the formula for profit is revenue minus cost. What you make minus what you spent. Break even occurs when the revenue equals the cost. That's when you break even. So you haven't made any money, but you also haven't lost any money. All right, so let's look at a business example, and that'll be it. Example 5. Suppose the revenue function is 9x, and the cost function that you calculated from all your sales and production is x cubed minus 6x squared plus 15x. In this example, x is equal to the millions of MP3 players made. Question is there a production level that maximizes profit? If so, what? So we're looking at maximizing profit. Remember, maximizing is a extrema. Since it's an extrema, we have to find the first derivative. So we have r of x is equal to 9x. So the marginal revenue is 9. The cost is x cubed minus 6x squared plus 15x. So the marginal cost is 3x squared minus 12x plus 15. So where do these two, what's our break-even point? So we have 9 equals 3x squared minus 12x plus 15. It's quadratic, so we have to set it equal to 0. So we subtract 9 from both sides. 15 minus 9 is 6. Okay. Yeah, so this thing can't be factored. So use the quadratic formula. We need A, which is the coefficient, which is 3, B, which is negative 12, and C is 6. So the formula we'll be using is the quadratic formula, negative B plus or minus B squared minus 4AC over 2A. Plug in what we know. B is negative 12. So it's negative 12 squared inside there. Minus 4 times A times C over 2 times A. Negative, negative makes it a positive 12. Negative 12 squared is 144. 6 times 4 is 24. Times 3 is 72 over 6. So we have 12 plus or minus 144 minus 72 is 72. And 72 is 9 times 8, 3 times 3, 4 times 2. So it's a 3 comes out and a 2 comes out. 3 times 2 is 6. And square root of 2 stays inside there. On the top, we can factor out a 6. 6's cancel. So our x value is 2 plus or minus radical 2. 2 plus radical 2 and 2 minus radical 2. So those are the x values. That's the x values to get maximum. So our y value, our cost value, is equal to 3x squared minus 12x plus 6. Now, we have to know which one gives us the maximum. To get the maximum, we look at the second derivative of our function. When we set r prime equals to c prime, that gave us this equation. So we have 6x minus 12 6 equals x minus 2. So we have to try both. X equals 2 plus radical 2 and x equals 2 minus radical 2. So at 2 plus radical 2, we get 6 times 2 plus radical 2 minus 2. That's put in there. The 2's cancel. So I have radical 2. So I have 6 radical 2. And the other one at 2 minus radical 2, which is 6, 2 minus radical 2. Two minus radical 2 minus 2. So the 2's cancel. So we have 6 times negative radical 2 makes it negative 6 radical 2. So this one, since it's positive, it opens up. So it's a minimum. This one is negative. It opens down. So the concave down. So it's a maximum. So at x equals 2 minus radical 2, we have a max. End of section. All right, that's it for that one. Good luck, everybody.